right, guys, so continuity, again, you know what it means for a function to be continuous. Like if you can trace the whole function without lifting your pencil, it's continuous. If there's a hole, if there's a jump, if there's an asymptote, it's not continuous. The way we're going to formally define that is with these three steps here. So is the function value defined? So we'll be talking about at a specific point. Then does the limit exist? And you might have to check the left and the right. And then the third is our number one and number two the same thing. So is the function value equal to the limit value? Okay. If that's true, then your function is continuous, and that's it. So let's try to sketch some pictures here that meet these conditions. So let's do the first one together. Condition 1 is true, but condition 2 does not hold. So the function is defined, but your limit does not exist. Well, visually, how does a limit not exist? Like, what do you see? Asymptote, or what if they're just like, yeah, they're just different places, right? So maybe my sketch looks something like, oh, I've got a line here with an open circle, and then I jump up here, filled in, more line. If we're talking about like at 1, do you see how the function value exists? Like there's a filled in dot there, but the limit would not exist. Does that make sense? So if I came from the left and from the right here, these two run into each other? Okay, so the limit does not exist. All right, you guys try to sketch pictures for these other two. So condition 2 is true. Hard to talk this morning. So the limit exists, but the function value doesn't exist. And then this one, 1 and 2 are true, but they don't equal each other. No, try to sketch it, and then we'll go over them, okay? Check in with each other. Do you guys have the same thing? Do your pictures match? What are we doing here? Are we ready, guys? All right, so condition 2 is true, but condition 1 does not hold. So the limit exists, but the function value does not exist. What did you guys draw for that? instead of condition 2 is true? Well, the conditions are listed up above, right? 2 is the limit one, 1 is the function value. You see it? That's what we're talking about. You're like, what are conditions 1 and 2? What'd we draw, Carly? Perfect. Yeah, just like, okay, there we go. Limit exists, function value does not exist. Doesn't have to be this graph, but that's the easiest one. Like, it's not true. Like, it doesn't exist. So the function value doesn't exist. Okay. All right, what about for the third one? So the function value exists and the limit exists, but they're not equal to each other. What does that look like? It looks very similar to the second one. Like, that's one way to draw it. So let me start with that. But then I put the function value as that dot down there. Do you guys see it? So function value is here. Limit is here. So they both exist, but they are not the same. Does that make sense? Okay. All right. So let's do this with the notation that we're going to have to show. I know you guys love notation so much. Okay, first we need to find the function value we're talking about as x equals 1. Okay, that's the x value we're focusing in on. So the first like bullet point or step you need to do is find f of 1. How do I do that in this piecewise function? Where do I plug 1 in? The bottom, yeah, because that's where it's actually equal. So that would be negative e to the 1 minus 1. Well, what is e to the 0, essentially? 1, and then there's a negative in front of it, so are we okay with getting negative 1 out of this? Okay. So your function value exists. We're good on that part. Now the limit, because it's piecewise, we have to show the limit from the left and the limit from the right. Are those the same thing? Okay. So you can go down here, you can go over to the right, wherever you feel like it's going to fit the best. I'll do limit of f of x as x approaches 1. We'll go from the left first. So where am I plugging in if I'm looking for the left-hand limit? The top. What do I get? I get 2 times 1 squared minus 3. Are we okay with negative 1 out of that? Okay. It's 1 from the left. Why? Okay. Why is what positive?
F of 1 you put negative 1, and then on the bottom you put x.
So I plugged 1 minus 1 in.
That negative 1 makes sense. I was confused that then we put f of x and negative x approaching positive 1. But we just got negative 1.
But the x value we're looking at is positive 1.
Oh, got it.
It's yeah, no, that's good. There's a lot of 1s and negative 1s happening here, so let's make sure we know where they all come from. All right, so now we need to do also with that the limit of f of x as x approaches 1 from the right. So where am I plugging that in? The bottom. Did we already plug it into that? What'd we get? Negative 1. Okay. Yeah, so what are we seeing here? Everything is coming up negative 1, right? So that means this is continuous. So let's write our third bullet point over here. The way you need to note it, f of 1 is equal to the limit of f of x as x approaches 1. Therefore, the 3 dots, f of x is continuous. You can abbreviate continuous at x equals 1. You do. Can't just be like a bunch of scribbly work with some negative 1s and then a yes at the end. Okay, that's not going to get you full credit. Carly?
Do we write
All of what is up there is necessary. So like bullet point number 1, function value. Bullet point number 2 is the limit stuff. Third one is that those two are actually equal, and then your conclusion. So there's like 4 pieces you have to write. Now, if you get here and it's like this didn't exist, you don't keep going with all the other steps. If these first ones don't exist, you're done. You just say it's not continuous. Okay. You okay, Ian? Are you sure? All right, guys. Try, I guess, example 3. Feels like number 2, but try example 3 for me.
Wait, can we just go straight to from the left to the right?
First thing would be g of 3. What is the function value? Start there. Then it's the left and right. Excuse me. Well, no, if it doesn't, then you tell me why. Why doesn't it? Why isn't it continuous?
Wait, how do we stay? Wait.
All right, let's go through it together. What are we getting for g of 3? Does that exist? 3, okay. When we do... Yeah, like if you tried to plug it in and it was like where an asymptote was or something, you'd be like, this doesn't exist.
So if you how do you know there's not, like, if you can't get an answer?
Well, you tell me, how do you know if something is undefined? Okay. Yeah. You know. This is, you just get a number? That's great. So let's do limit of g of x as x approaches 3 from the left. So we plug it into the top piece. What do we get? 4. And from the right, we already know is what? Okay. So these, not the same, right? Not equal. All right, therefore, the limit does not exist. And that means g of x is not continuous at x equals 3. It's because the limit does not exist. Like those two together are the, it's not continuous and the y. Does that make sense? Doing okay so far, guys? Okay. All right, the fourth one, find a value for c such that this is continuous for all numbers. All right. We did one of these, I don't even know, last week sometime. Try one of these. See if you can figure out c. Think about what has to happen. I'll give you a minute. Your answer is a fraction, just so you know. Yes, and you also have to do like an equation with algebra. So kind of, like you're thinking through those steps though.
Bro, what the heck?
Ben, you gonna try it all today? Ben.
Bro lost his friend.
I know, we're all very sad.
I don't think I ever actually counted how many seniors we had in here, and there's more than I realized. How we doing, guys? Do we have a fraction yet? Yeah? It's okay. This is really more about solving for C. Yeah. I'll go through it up here, but what'd you get for C?
14 over 9.
Not quite.
11 over 8.
Yes.
Oh, I was right. Oh, I erased all my work.
I was right
They
too.
were right. Well, you were right. I was right.
I did not.
You were right
I
because I
lost.
was right. All right, let's go through it, guys.
You even get that wrong. That's so easy.
Okay, what do we know needs to be true for this to be a continuous function? Yeah, the two have to equal each other. If they equal each other, that's also what the function value is going to equal because that's one of the pieces. It's a little trickier if there's three pieces and one of them has to be a certain value. But what you can do algebraically, we're just talking about c times 3 squared minus 2 times 3 has to equal 5 plus c. And then we can just go from there, 9c minus 6. So 8c equals 11. So guys, on these kind of problems where you're finding c, I'm going to be less picky on notation. I just want to see if you can... What? No. What? But where would this graph have a discontinuity? I see what you're saying, Ed. Do you see why we're plugging in 3? Think if we were graphing it. This is not at all what it looks like. But I've got like some sort of parabola thing going on and then a line. Like I need them to meet. Like I need them to run into each other at this x value of 3. So that's why we use the 3. Totally get why you were saying it. At first I was like, wait, what? There's no infinities here? I got you now. All right, let's keep, oh, yes, for sure. Yeah, always yell at me. When needed. Not all the time, just when needed, okay? No, you don't have to draw the picture. That was just me explaining it to Reem. No, with these algebra ones where you're finding C, I am fine with you just going through the algebra. Okay? All right, so we'll get rid of
Wait,
this.
sorry, I lost
Yeah.
Why don't they do what it's
So you could, like, if you wanted to afterwards to show, like, limit of k of x as x approaches 3 from the left, and say, okay, I'm plugging in my 11/8, my 3 squared minus 2 times 3, like, to see what that value is, and then you could do it from the right. But that's, what we're trying to find is just the C value. Like, I'm more concerned with, can you do this algebra to find the C? Okay.
So all you need is the values.
Yeah, you just need what's on the left over here. Does that make sense? Yeah, it's a different question than the other ones. If it says, like, is it continuous, like, then you have to do your bullet points and think about it from there. All right. There are two types of discontinuities, or two categories, if you will. There's removable and non-removable. Removable is one of those words when I'm spelling it that I think I did spell it wrong. There's not an E. Removable. You ever have those words that you're like writing it and you're like, that just looks wrong? That's one for me. Okay, so let's think about the types of discontinuities that you guys know. There's a hole, there's a jump, and there's an asymptote. Okay? One of these is removable. Which one do you think is removable?
What do you mean by removable?
Like the X value gets like plucked out. The hole, yes. So the hole is the only kind. So we'll put it down here in the category of removable. So possible equation, how do we find a hole? Like algebraically, what do we see that we know creates a hole? Like factors get canceled out? Yeah. So let's say we had something like x plus 3 times x minus 3 over x minus 3. Right? That's going to cancel out and make a hole. And then your graph would be something like a line with that hole. Okay? Again, you guys are familiar with this part, right? We've done this year. I believe you did it last year in Algebra 2. So.
What do you mean by
So that's just the category that a hole falls into. Do you see how we remove the factor? Like, think about it that way.
how come that doesn't leave a zero at the bottom when you cross?
Okay, if I have 3 divided by 3, does that leave a 0 anywhere, or what does it leave? Okay.
So it's x plus 3 over 1.
Right, which is really just a line, x plus 3. Yeah? Okay. All right, so our other category is non-removable. So we have two types there. We have a jump, and we have the vertical asymptote, okay? All right, so a jump, those come from piecewise equations. Can I squeeze one in here? Let's say like x when x is greater than or equal to 0, x minus 3 when x is less than 0. There's my lovely graph. We're keeping it simple here. Again, you know what that is, right? Nothing new here. Vertical asymptote, that comes from where your denominator is equal to 0. So let's say we had like 3 over x minus 2. Where's the asymptote going to be? 2, right? 1, 2. Plug in points, but this is your general shape. So the vertical asymptotes, those are in those rational graphs. All right, we okay? Okay, let's look at this graph down below. So that whole weird looking graph is f of x. I want to know every x value where this function is not continuous, and then I want you to classify it as removable or not removable. Okay? So take a minute here. There's 4 places of discontinuity. I'll tell you that, 4 different x values. All right, guys, we got all 4? Okay, let's do removable first. What are the 2 removable? Like x equals what and what? That one is not a removable because that's a jump. X equals 3, yes, and yes, okay. Okay, wait, too many questions open. But what is happening right there?
But also at -1, the same thing.
It's no, this is not a hole. This is an endpoint that's an open circle. A hole happens in the middle of a graph, like in the middle of a line, right? You see the difference? Okay.
Yeah, I thought 3 was a jump.
3 is not a jump. Do you see how this line is moving, going along, and then we have this open circle, and then it continues? That's different than here we are, open circle, jump to the other piece. This is just the function value. Like if I asked you f of 3, that is the only time that dot matters. Okay? All right, so those 2 were both holes. So where are my 2 non-removable then? -1 and 1. Yes, -1, that's a jump. If you want to label this to help remind yourself. 1 was a vertical asymptote. These 2 were both holes. Okay. Do we see the difference visually? Okay. The hole and the open endpoint, I know that's always tricky. All right, questions? All right, so let's figure out where this is not continuous. What do you think we need to do? Factor, yes. So let's write g of x in factored form. What does that numerator factor into?
X plus 8.
Good, x plus 8 and x minus 5. All right, what does the denominator factor into? Okay,
There's a hole.
there is a hole.
So excited.
Woo, there's a hole. Okay, so a hole that is removable, right? I like the enthusiasm. Okay, where does that happen? At x equals what? 5. Yes. Now, if you were actually graphing this, you'd need to find the y value by plugging it into what's left. All of those things we did when we graphed rationals. You're not graphing it today, though. You are just finding the discontinuities. Okay? We have one other discontinuity. It is a non-removable. We were just not as excited about the asymptote. Man, okay. Yes, there is a vertical asymptote. Make yourself a note if you need to. Where does that happen? Yes. Okay. So I'm not looking for crazy notation on these either. Just can you find those different points?
Other non-removable is the point, right? There's no jump.
No jump. Since this isn't piecewise, you're probably not going to have a jump. Okay. Now, example 3 is so much piecewise, probably a jump in there somewhere. Okay. All right, let's look at 3. Everybody good with the second one there? Okay. All right. No one's yelling at me. So. Okay, determine where this has a discontinuity. There are so many pieces of this piecewise. So what you need to do is check each left and right and left and right and left and right, like of the limits. Yeah, so you need to check it at -2, at 1, and at 3. So let's do -2 first. Limit of h of x as x approaches -2 from the left. What do we get? What do we get? Yes. Plug it into that top piece. That is from the left. Now we need to check limit as we approach -2 from the right. Do you guys see how that would be the next piece that I'm plugging it into? Okay, what do I get there? Okay. What does that mean? Like, yeah, these continuous, okay? So we don't need to write,
Would you plug it into
for the second one, the x squared minus 9. Because that would be -2 from the right over here.
choose to plug in -2?
So you're gonna pick, do you see how they have a common -2? Yep, and then I'm gonna pick the 1 next, and then I'm gonna pick the 3, right? We see it?
Okay, so you're gonna plug into the x squared.
Yes. Yep. And since these match, no discontinuity, right? Okay. Now we go to the 1. So limit of h of x as x approaches 1 from the left. Do you guys see how that's the x squared minus 9? Okay, what do I get there? -8. All right, good. And then we also do limit of h of x as x approaches 1 from the right. Are you following me down? Now we're on 3x plus 2. What do we get? 5. Okay, not matching. What does that mean? Yeah, it means we have a jump. So removable. I would include jump when you say that. And that's,
Yeah, jump.
oh, I'm sorry, none. Thank you. Good job, guys. At x equals 1, right? So there's 1 discontinuity. All right, we need to keep going with 3 over here. So limit of h of x as x approaches 3 from the left. What do we get? 11.
So just straight up, you get equal to 11.
And as x, Well, let's think about it. We did get matching. I very much agree with that. But look at my two inequalities. Is the 3 actually included with either of them?
It would be a whole.
It would be a hole, yes.
Actually,
So you needed to figure out, was it a jump or a hole? There's definitely a discontinuity here. If they hadn't matched, it would have been a jump. Since they do match but not included, that's a hole. So that is removable. Making sense? Questions? Making sense? Okay. It's not too bad. All right, let's keep going. All right, you guys try this one. This is back to your 3 bullet points. Is it continuous at x equals 2? So does f of 2 exist? Limit as x approaches 2. And then are they the same? Okay, so try that. It's like what we were doing at the beginning. Okay. How do you do it? Go back and look at the first ones if you're not sure. This is back to what we were doing at the very beginning. Let's see. Yeah.
11 and 11. And this, we had -5 and negative. This was continuous, but this was a whole. How did we not include this?
So do you see how this was checking -2, right?
Yeah.
Do you see how -2 is actually included on this one?
Yeah,
We have to work
yeah.
with it. But look at the 3s. Is the 3 included anywhere?
Oh no.
No, so it'd be an open circle, like on both parts.
Okay, got it. So here the 2 would be included.
Yep.
I know.
All right, guys, let's walk through this one. Function value, everybody okay with getting 3 when we plug the 2 in? Okay. Then we got to do our limits. Limit of f of x as x approaches 2 from the left. When you plug it into that top piece, what do you get? Approximately, exactly 3. And then the limit of f of x as x approaches 2 from the right. Plugging it in here, what do we get? 3. Okay, same, right? So that means the limit exists. Well, I think we'll be okay.
Everyone's cold.
I'm fine.
I'm good. I'm kind of. It's kind of warm.
Now you're good? You're lady all class? Are you cool?
All right, the third thing you need to write is that f of 2 is equal to the limit of the function as x approaches 2. Okay, what does that mean? What's your conclusion?
Oh, therefore, f of x is continuous at x equals 3. Or x equals 0.
Perfect, yeah. Yes.
Why do we use the triple dots in there for?
Like who invented that?
Yeah.
I don't know. I do not know the history of the triple dots.
There's no reason.
All right, guys, last one. One more of these find the value of C type of questions. Are we good notation-wise? Like, we get it? I know you don't like it, like it's a lot to write that's kind of redundant, but you do have to write all of that. Remember, C, I'm just more concerned with your algebra than notation on that one, okay? So try that last one, see if you can find the value of C.
Boy, elementary school and middle school. And then William walks over. Yeah, that's all. I made it out the bond, bro. I made it out. I made it out the bond, bro. I made it out. That's it's a structure. Bro, have you seen this crazy?
You guys got C? Yes. Okay. So guys, we need to plug in the 1. We know that part. Yay? Okay. I want to do a quizzes. I'm struggling to get quizzes to load, so get out your laptops. Hopefully we'll get there at the same time.